Morning, Year 7. Right, okay, so I'm going to talk you through what was going on with the blueberries if you managed to have a little go, or if you've watched the video and seen what happened when I did it. Okay, so the blueberries were acting as something that we call an indicator, okay, which is allowing us to know whether a solution is acid, whether it's alkali, or whether it's neither of those things. And if it's neither of those things, then we call it neutral. Okay, so we need some sort of idea of an indicator that can let us know whether a chemical is going to be hazardous or not. Okay, so just bear with me, it's not working. Right, so like I said, acids and alkalis, they can both be useful. Okay, so things like cleaning products are alkaline, things like lemon juice and vinegar are acid, so some of them are not harmful at all, but some of them are. Okay, so we need to be able to know which is which. And acids and alkalis are chemical opposites. Okay, so they are opposite one another, and we'll talk about that a little bit more tomorrow. Okay, so like I said, we need to be able to use something to let us know whether a solution is acid, alkali or neutral, because quite often they all look exactly the same. Okay, they just look like a liquid. So in this case, these are some examples of, well, in fact, right, see if you can guess what their examples are before I tell you. Okay, so these all have something in common. Okay, so these are actually, all of these would be acid. Okay, so all of those, apart from the ants, they're largely edible. Okay, so they're not things that are going to cause us any hazards. They're quite safe. You've got the citrus fruit, which is acidic, so you might have tested lemon juice or orange juice. The sweet, the tangfastics, the ones that sort of get you in the jaw when they're those sours, that would be acidic if we dissolved it into water. Any kind of fizzy pop is also slightly acidic. It's not just Coke. Any sort of anything with fizz in it. Vinegar, we've talked about before. Nettle stings is an acidic solution that they actually spike you with, and that's what makes it hurt. And an ant as well. An ant will bite you. They don't tend to over here unless you really annoy them, but ants can bite you, and it really does hurt because they inject you with something called malic acid, and that's what gives you the irritation and the itch. Okay, so it's a safety sort of mechanism, or a way of protecting themselves from predators. Okay, so all of these contain acids. Now, like we said, they're a group of chemicals. They're found in all sorts of different things. Okay, most of these are safe to handle. Okay, and a lot of them we can actually eat because they are what we call weak acids. Okay, now at home they would all have a sour taste. So you must never ever taste anything in school or in the lab or anything. But if it's a food product, then it would taste quite sour. Okay, so you've got ethanoic acid, which is in vinegar. You've got citric acid, which is in lemons and citrus fruits, so things like limes and grapefruit as well. If you've ever had a cut on your finger and you get lemon juice in it, it does sting like crazy. Okay, so they can still hurt your skin. Other acids that you've got there, you've got carbonic acid, so anything that's fizzy contains bubbles of carbon dioxide, and the carbon dioxide dissolves to make the fizzy drink slightly acid, which is why people always say about it harming your teeth. Okay, as well as all the sugar, it's also quite acidic. You get tannic acid in tea. Vitamin C, if you take vitamin C tablets, that contains ascorbic acid. We tend not to use their acid names because it sounds all a little bit scary. So, some facts about them. They will taste sour. If they are a strong acid, and I'll talk to you about the difference about weak and strong in a second, but they are corrosive. So this hazard label up here was what I asked you to do for the first lesson in this topic, thinking about what they can do, and they burn your skin. Okay, not like a heat burn, but it will eat away your skin and other materials as well. It's not just your skin. Now, one indicator that we can use is called litmus. Okay, and it's a bit like the blueberries were. So litmus will turn red in acid, okay, and I'll talk to you about different indicators in a second. And they have a pH of less than 7. Now hopefully that will also make sense in a few minutes, okay, and they can be neutralised with alkalis. Again, that is something that we'll come on to in tomorrow's lesson, okay. So some things about alkalis. They feel soapy, so quite often if you get bleach on your hands, which you need to wash off straight away, but it makes your skin feel slippery, okay. So if you get alkali on your skin, it makes it feel slippery and soapy. So they are often used in household cleaning products, so you do need to be careful. Even though they're the opposite of acids, they can still be corrosive and dangerous, okay. So they can still actually break down your skin. We call this reaction caustic, okay. So rather than corrosive, we use the corrosive sticker, but we say that in alkalis the word is caustic. So they make your skin feel slimy. Now in this case, the indicator, they will turn red litmus blue, okay. So that's what's that top picture up there. So they will turn litmus indicator blue. So again, you can see that they're opposite colours. They've got a pH of more than 7, and they can be neutralised with acids. Now, this is litmus. Now, litmus is really handy in that in acid it turns red, and in alkali it turns blue, right? So like the blueberries did, it helps us know if there's a colourless, clear solution that we don't know what it is, we can test it, and it would turn red in acid and blue in alkali, okay? Now, that's useful. However, it doesn't tell us if it's a weak acid or a strong acid, or the same with alkalis, and it doesn't show us which one's neutral. So we have other things, other indicators that allow us to have a whole range of the strength of different acids and alkalis, and the most common one that we use is a mixture of indicators, which is called universal indicator. Okay, now universal indicator you can actually use to make this chart. Now this is the pH chart. Now it's a bit odd because 7 is the middle. Okay, so rather than working from 0 up to 14, 7 is the middle, right? And 7 is neutral. So universal indicator is green in a neutral solution. So if universal indicator, the indicator itself is green, okay, so when you get a bottle of it, it's green, but if you add it to something that is neutral, it will stay green. So if you put it into water, it would stay green, and that tells you it's got a pH of 7 and it is a neutral solution. Now, acids are all below 7, and they get stronger the further you move away from number 7. Okay, so 6 is only it's just about acid. 5 is a little bit more acidic, and then you go all the way along, okay, until you get to the strongest acid, which is 1 or 0. So we give it a value and it tells you the colour. So a very strong acid would be red. Now the other end of the scale are the alkalis. Now again, it works, let me just put this up, oh no, I'll put the other in a second. It works the other way, okay, so in this case, 8, because it's just past number 7, is only just an alkali, okay, so pH 8, that's sort of just off green colour, turning slightly bluish, that is only just an alkali, so it's a weak alkali. And then as you move up the scale towards number 14, that is the strongest alkali. So number 14 is the strongest alkali. So alkalis, we say, have all got a pH above 7. Okay, so acids have got a pH below 7, alkalis have got pH above 7. And then remember that the furthest ends of your scale, so the furthest end here and the furthest end here, are the strongest alkalis. The strongest acids and the strongest alkalis. Okay. Now you've got 2 little questions here. Just have a little think about. Okay. So for example, pause the video and then you see if you can answer them, and then I'll tell you the answers. So a weak acid it's just past neutral, so it could be number 6, it could be number 5. Those are both quite weak acids. And then the strong alkali, we need to look at the other end of the scale because we're looking at the opposite end, the alkali end. And if it's the strongest, it would be maybe number 13 or number 14, and it turns that very, very dark blue purple colour. Okay, very, very dark purple. Okay, now what you're going to do is I've given you a sheet on class charts, and it lists a whole load of different acids and alkalis, and it gives you their pH number. Now what you're going to have to do is draw out a line like this. You can colour it if you've got coloured pencils, that would be lovely, but you're going to draw me out a line that goes from 0 to 14, and then you are going to add either a label or a little drawing or an actual, if you've got magazines at home you could cut out and stick on, all of these different solutions that you are going to put into the right place on your pH scale. Okay, so you might need a big piece of paper if you've got one, or maybe stick 2 together because you're going to need quite a bit of room. Okay, but get really creative with it. If you'd like to draw the pictures, that's absolutely brilliant. And then send me a photo, please.